Today we will discuss another type of progression or sequence, and that is geometric progression. And the meaning of this concept is that if you take the ratio, that means second term by first term will be equal to third term by second term, then that will be fourth term by third term. This ratio will be constant, and that is called common ratio, because the ratio is common, fixed. So in GP we have the ratio to be fixed. Like if you take 3, then 6, then 12, then 24, what we are finding that this is actually GP series or geometric progression also, because 3 is 6 by 3 is 2, and 12 by 6 is also 2, 24 by 12 is also 2. So in all the cases ratio of the numbers is 2, so that is common ratio. The first number we always denote by A. Here also, as we have seen in arithmetic progression, we have two types of questions. First is the term and the second is sum. So if we want to know the term of a nth term of a GP, Tn, nth term, Tn means nth term of a GP will be A, that is the first term, and the R, that is common ratio to the power n minus 1. Whereas the sum of n terms will be A and then R to the power n minus 1 by R minus 1. This is multiplied with A, but there is a provision that R should be greater than 1 or R can be less than minus 1. That means the value of R should be more than 1 or R should be less than minus 1. So it can't be possible that R is equal to 1. And secondly, it can be considered that normal idea of this sum will be increasing GP. The GP is increasing from term to term. But the second idea is another one, 1 into 1 minus R to the power n by 1 minus R. And this is applicable when R is lying between minus 1 from minus 1 before plus 1, because R cannot be 1 in any case, because 1 minus R, that is the denominator, will become 0. So both the possibilities can be considered. So we can take an example. We have a sequence, and the sequence normally we write the first term is A, then second term is AR, then third term is AR square. In this way we proceed. Now we have a example like find the 10th term and sum of 10 terms. Both I am asking. Sum of 10 terms of the sequence. I am not identifying the sequence. I am just saying that sequence is like 2, then 6, then 18, then 54, and this way. So what we need to know, that is 10th term, T10. What is the formula? A is 2, first term 2. What is the ratio? If I divide 6 by 2, that becomes 3, and that is always fixed. That is 18 by 6 is also 3, 54 by 18 is also 3. So the answer to this question, the 10th term, will be 2 into 3 to the power 10 minus 1, because the formula is A into R to the power n minus 1. That means it's a big result. 3 to the power n minus 1 is 3 to the power 10 minus 1 is 9. So our result is 2 into 3 to the power 9, and 3 to the power 9, 19683, and that is multiplied with 2. That means 2 times 19683, and the final answer is 39366. 39366 is the 10th term of this sequence, that is 2, 6, 18, 54. Now the second question is sum. Sum means the total of all the terms up to 10 terms. So that will be, here R is 2, that means it is greater than 1. So it is an increasing GP, which is clear in this example, 2, 6, 18. So our sum of 10 terms will be A, that is 2. R is not 2, I am sorry, this R is 3. So it is not correct that R is 2, R should be 3. and R3 is also greater than 1, that it means it is a increasing GP. So R is 3 means greater than 1. So our result will be based on the first formula of the sum, that is A is 2 R to the power n, and n is 10 as before. We have seen 3 to the power 10 minus 1 by 3 minus 1. Now 3 to the power 10 we have a big result, because 3 to the power 9 just now we have seen, that is 19683. That means that will be 3 to the power 10 is 59049 minus 1. That means 59, this is 2 and the denominator is also 2. 3 minus 1 is 2. So this 2 and denominator 2 will be cancelled. So our result will be 59048. So this is the final answer. So it is a case of how to find out the sum and the term. Now in GP we have one more concept, which is like fourth term of a GP. We can take an example. Fourth term of a GP is given as 27, and next is seventh term of the GP, the same GP. Seventh term of the GP is given as 729, and the question is find the sum of, that means total. We want to find 8 terms. Find the sum of 8 terms of the GP. Therefore, what we need, first of all, fourth term, we don't know A, we don't know R, so we can say A R, that is the first term, common ratio we don't know both, to the power 4 minus 1, and that is AR cube, and this is 27. And the seventh term is A R to the power 7 minus 1, that will be AR to the power 6 is 729. It's a very easy task. We will divide, because if I divide this 2, then A will be cancelled. If I divide this 2, then A will be cancelled. That means AR to the power 6 divided by AR to the power 3, 729 by 27. A is cancelled, R 6 and R is 3 power. The power is reduced to R to the power 3, 6 minus 3, and that is 27. So R is 27, hence we find that R is 3, because 3 to the power 3 is 27. We know the power is same, then base must be same. So here R to the power 3 is 3 to the power 3, therefore R is 3. We have R is 3. Now we know A R to the power 3 is 27, but R is just now found as, we have found R as 3. So our result will be A, that is we don't know. 3 to the power 3 is 27, hence 27 by 27, because 3 to the power 3 is 27, A is 1. So we know A, we know R, and we need to know the total of 8 terms. So our answer will be, sum of 8 terms will be A, that is 1, 3 to the power, because R is 3, to the power 8 minus 1 by 3 minus 1. So our final answer will be 6560 by 2, and that is 6560, because 3 to the power 8 6561, and then minus 1 6560. The final answer is 6560 by 2, and the result is 3280. This is all about this GP, but GP has one particular type of problems, which is not exactly GP, but it can be converted to GP. It can be find the sum of, it's a very popular question, find the sum of n terms of the sequence. It's a sequence. The sequence is 7 7 7 7 7 7 then 7 7 7. That means this is a sequence of number, but this number is not GP. So this is a very important type of questions. What we can do in this question, we need to know the sum of n terms. So we are adding 7, then 77, then 777. In this way we are proceeding. If you take 7 common, then what you are finding, that is 1, then 11, then 111, then no such n times. to n terms, but no real sequence is observed here. What we can do, we can create the sequence as a GP sequence. Now if you multiply 9 in all the terms and we divide that with 9, that means 9 by 9, 99 by 9, 999 by 9. That means if I take 9 from the denominator outside, then it will be 9 plus 99 plus 999 to n terms. Now if you observe, we are having one very clear idea that 9 is 10 minus 1. Then 99 is 10 square minus 1. Then 999 is 10 cube minus 1. So we are finding this is continuing up to n terms. Therefore, if you look at the sequence by segregating the terms, by separating the terms, we will find that 10, 10 square, 10 cube, this will come. 7 by 9, then we are having 10, 10 square, 10 cube, this way n terms. This is a GP, clear GP, because 10 is the first term, common ratio is 10, and minus 1, minus 1, minus 1 to n terms. That means all the brackets which are, we are having n brackets, all are subtracted by 1. So it will be 1 into n, because all the values are subtracted by 1. So n times. So our answer is now clearly in GP. 7 by 9 is outside, and this is A, first term. Then R, 10, because if you divide 100 by 10, 1000 by 100, all are 10. That is the R. 10 to the power n minus 1 by 10 minus 1 minus n. So final answer we can write, this is 10 by 9, 10 to the power n minus 1 minus n. This is a very important type of problem. Now one last idea of GP I can discuss now here. Last idea, and that is infinite GP. This is very, very important type. Infinite GP is GP, but that will be infinity. Means the last term is not a finite number. So we can have this idea AR square up to infinite number of terms. So we have a very simple formula to remember. Condition is R value, the value of R should not be more than 1. It should be less than 1. That means it's a case of total sum of infinity of a GP. Means all the terms, if you continue, it is a decreasing GP ultimately. R is less than 1. Then sum will be A by 1 minus R. Like we can have an example, 0.7 plus 0.07 plus 0.007 in this way to infinity. So what will be the total of this series? And the sum will be A. A is the first term, that is 0.7, and the ratio is 0.7 by 0.07 by 0.7, that is 0.1. Then 0.007 by 0.7. So if I divide all the successive terms, we are getting the ratio to be 0.1. So 1 minus 0.1, that means we are having the result as 0.7 by 0.9, which is 7 by 9. 7 by 9, if you calculate, you will find a idea that 7 by 9 is a non-terminating decimal number. Because if you divide 7 by 9, it comes to 0.777 in this way. So another idea it is giving that any non-terminating decimal number can be expressed as a fraction from the infinite GP. So this is the idea of infinite GP. So this is all about geometric progression, the basic ideas for the today's discussion.